Hi, I'm Santosh Subramania. I'm currently working as a principal data security engineer in Autodesk, leading enterprise DSPM and DLP program. So in this video, I'll share my research briefly. So I'll provide the context on what my research is based on. So as we are aware, security requires deterministic output, and especially where the output from a specific security tool is used as evidence or an artifact for further work. So as you are aware that in especially in case of a DSPM, so a lot of security companies are using LLMs as classifiers, and also we are seeing many organizations are using LLM for various security tools. Either it can be for triaging, or it can be extracting evidence, which can be further used for compliance purposes. But in this video, I'll show that as we are aware that LLMs are by nature probabilistic, and we are aware that the traditional security tools like DLP and previous DSPMs were using regular expressions which are deterministic in nature. But if you are using LLMs, what are the consequences of that in case of security? So let me show briefly about what I have done here. I'll share my screen. So what I'll be testing in this case is that, so we know that there are two types of, we know that there's different attacks, right? One is homoglyphic and zero with space attack. This is quite common, and this is not something new. But let's say that attacker can use these two techniques and obfuscate the data, and this data is present in the organization environment, organization data estate, and we are using DSPM to scan these things and identify them. And so this is one of the techniques attacker can use to exfiltrate the data so that they don't get detected by DLP or any other security tools, right? Because regex fails. And so as mentioned, right, if DSPM is using LLMs to classify and they look for these content, for example, AWS key or social security number. And what we are seeing is when LLMs are used, they are basically breaking the chain of custody. Or in other words, when they search for these sensitive data and output this sensitive data, it's not outputting the data as it is in the raw bytes. In fact, it is many of the times it is actually healing this data. In other words, it is stripping off the zero bit spaces and providing the actual canonicalized normalized data, which is again something which is not present in the data environment, because the data which is present in the environment is the obfuscated data. And if this output data, which is used uh, to trigger an alert for the SOC to investigate, they will not find this data because this is not the actual data which is present in data estate. Likewise, we also saw that it is fabricating the data as well, wherein certain bytes are replaced by another byte. It is stripping off uh, one or two bytes as well. So this is what I'll be showing in this demo. So, so this is the script I'll be using it. So as you can see, the zero bit space is represented by hex bytes E288B. And the prompt I'll be using is your data formatting tool, right? And I'm providing the LLM to specifically follow this instruction of extracting the social security number as well as the AWS key. And ZWS test is the file which has got this sensitive data. And as you can see, I'm using Llama 3 70 billion parameter. And this is the temperature I'll be using is 0.0, because temperature 0 is the most deterministic output that you can expect from a LLM. And I'll be running this, I'll be feeding this particular prompt and the data, which is the zero width test case to the model, and the model will output this into the model dot output dot text. And what I'll be doing next is I'll show the hex bytes of what was outputted to the outputted by the LLM. And this particular piece of code, Python script, will compare byte by byte what was present in the source file and what was output from the LLM, right? And then this piece of code will basically compare the byte by byte and output what exact bytes were changed. And it will print either the data was healed. If it is faithful, means whatever the bytes was present in the file, the exact bytes were, including the obfuscation, was preserved and outputted. Healed, it basically stripped off the 0-bit spaces and only outputted uh, the the clean normalized data, but this breaks the chain of custody and corrupted. So this is fabricated data. This basically completely spoils the evidence. So let me show that. So this is a server I'm running. Llama server is currently running. And from here, so this is the script, I'll be using it. And so this is the source file. This is hex bytes, which is present in the source file, 0-bit space. And now model is outputting that. So it has taken the prompt and it is running the prompt on the file, 0-bit space test case. It is searching for this AWS key as well as social security number. And it basically gave the output. This is the output it gave in hex bytes, as you can see. Now we'll compare. In AWS credential, the source was this, as you can see. This is a source file. This is a source data. The output is this. This is the hex bytes of the output, and verdict is corrupted. Why? Because the reported value, which is output, is fabricated. It is neither in the source nor the real value. We'll see what was changed. So likewise, social security number also healed. So which means to they say that the source was this SSN number, and it stripped off this 200B slash 200B, which is the 0-bit space, and just provided the normalized form, which is again not good because that is not what is present in the file, which is in the data estate. Because this is when a SOC searches for it, they need the exact data to search, or else they'll not find the data. So again, this breaks the chain of custody. Both fabricated obviously affects, and that is not what is present in the data estate, nor the normalized one, because it breaks chain of custody. And what was changed here? In case of AWS credentials, as you can see, the model stripped off 3 0-bit spaces to E80AB, and the mutation happened here, wherein the source 49, hex bytes 49, that is I, was replaced by D. So basically, it fabricated it. Likewise, in case of SSN, it removed the 0-bit space, which is again, as I said, this is not the raw bytes. So this clearly shows that LLM is modifying, fabricating it, corrupting it, or healing it, which is not definitely what is needed. And this proves that LLM is not deterministic. So, and any, if this data, this data which is output from the LLM is used to trigger an alert for the SOC to uh, do further analysis on this thing, they'll definitely not find the data. And what they basically think is this is a false positive in LLM and they close the ticket. But if this data is exfiltrated out by the attacker because this was triggered, but they thought this is a false positive because it was never present in the estate, the attacker will get the data out and he gets a clean pass. Yeah. So I'll be talking more about this. We have a couple of more cases, and I'll be explaining that in detail in the conference talk. Thank you.